If you use DynamoDB without realizing this, any app you build will eventually become slow and painful to fix. Dynamo seems like just another database with tables, so you create separate tables for all your data. And at first, this works, but then your app grows, you get more users, and all of a sudden, your app starts to feel slow. You start looking for ways to speed things up. But in DynamoDB, performance isn't something you fix later. It's something you design for from the very beginning. Today, I'm breaking down a powerful technique called single table design. And by the end of this video, you'll understand how to keep your database blazing fast, even as your app grows to a ton of users. Now, there's one crucial detail about DynamoDB people often don't fully internalize. And if you miss it, it will lead you down the wrong path. In a typical SQL database, there's a natural way to structure your data, creating a table for each of your entities. In an e-commerce app, users go in a users table, and orders, well, in an orders table. Each table has its own columns, and you connect them using foreign keys. If you need a user and all their orders, that's easy in SQL. You just use a join. With a join, the database combines rows from multiple tables into one clean result. All right, here's the thing about DynamoDB. There are no joins. Let me say that again. DynamoDB does not support joins. There isn't a way to ask Dynamo to combine data from different tables. So if you model DynamoDB the same way you model SQL databases, users in one table, orders in another table, your application now has to first read the user from the users table, then read all the orders from the orders table. Finally, use all those results to do a manual join in the code. This is added complexity, and that extra network request is added latency. As your data grows, this only gets worse, resulting in slower read. You might wonder why Dynamo doesn't come with something as basic as joins. Well, the reason's really simple. Joins just don't scale well. When your app's data gets large, it needs to be spread across many computers. And doing joins across machines is both slow and expensive. So Dynamo makes a conscious trade-off. No joins, but extremely fast, predictable reads at scale, as long as you use it as intended. And as a result, Dynamo pushes you in a different direction. If you can't rely on joining the data when you read it, what if you pre-join the data when you write it instead? Later, you can read everything in a single request. And that is the core idea behind single table design. We'll go into much more detail into how to actually do that. But to make it work, we need to understand how a DynamoDB table is actually structured. At a high level, a table is just a set of rows or items. Each item has a unique ID called a primary key. In most cases, the primary key consists of two parts. The first part is the partition key. It determines where your data is actually stored. The way it works is Dynamo splits up your data into logical partitions, and the partition key determines which partition your data lives in. The second part is called the sort key. The sort key determines how items are ordered within a partition. Together, the partition key and the sort key uniquely identifies an item. It's like an address. The first part gets you to the right building. The second part, it gets you to the right apartment inside that building. You can have many items with the same partition key as long as their sort keys are different. All those items together form what's called an item collection. Item collections are powerful. Every item in the collection lives on the same partition, which means reading all those items in a single request is extremely fast. Of course, this doesn't mean you can put all your data in a single partition. That would defeat the whole purpose of partitioning in the first place. Okay, here's where sort keys come into the picture. When you query DynamoDB, you need to provide the full partition key. Before the sort key, you get more flexibility. You don't need the full value. In fact, you can do partial matches on the sort key. Using something like the begins with operator, you can get all the items whose sort key begins with a certain prefix. This is one of the most powerful features in DynamoDB, and it's something we'll use a ton. Now, you might be wondering about the rest of the columns in the table. These are often called non-key attributes or just attributes. These are much more flexible. DynamoDB doesn't enforce a schema on them at all, which means each item in a table can have a completely different set of attributes. No SQL, am I right? But here's the important thing to understand. When it comes to queries, DynamoDB only cares about two fields, the partition key and the sort key. That's it. It completely ignores everything else. You can use those other attributes to filter the results you get back from the query only after the query is run. And if you try otherwise, you'll have no choice but to do a full table scan and filter, and that does not scale. So this means something pretty serious. One of the most important decisions you make in DynamoDB is choosing the right values for just 2 fields. And yet, this step is almost always rushed or skipped entirely. So the real question is, how do you actually know what values belong in the partition key and sort key? Okay, let's say you have a basic e-commerce app with the following entities: users, orders, user profiles, and product data. Before you think about keys, the first thing you're going to ask is, what are the different ways the app will need to read this data? In this case, some common access patterns might be get all the orders for a user, get a user's profile, and get all the products for a particular order. With these access patterns explicitly listed out, you actually have all the data you need to decide the partition and sort key values. For access pattern number 1, since you need the details for a particular user, a natural choice for the partition key is the user ID. Now, as a side note, a common DynamoDB convention is to prefix the values with the entity name and a hash. So you might add a user hash and then the user ID. For the sort key, you need to represent individual orders. So you can use a similar structure with an order prefix and the order ID. And that's it for this access pattern. Now, when you want to get all the orders for a user, you do the following DynamoDB query. You look for the partition key equal to the user prefix and user ID, and with a sort key that begins with the order prefix. All of those orders live in the same item collection. So this query is very efficient. All right, for access pattern number 2, you can use almost the exact same idea. Since you're still interested in the user, you can just use the same partition key. And for the sort key, assuming each user has a single profile, you can just use something like a constant value. Now, getting a user's profile is just another query on that same partition. It's really that simple. Now, for this final access pattern, things are a little bit different. You're interested in details about the order entity instead of the user. So for the partition key, you can use the order ID instead with the order prefix. And for the sort key, you guessed it, you can just use the same structure with the product ID. Since all the products for a given order live under the same item collection, you can read them all in a single fast query. For the rest of the columns and attributes, you can choose whatever values you need. Remember, for queries in DynamoDB, we only care about 2 values, the partition key and the sort key values. So that's all there is to it. Okay, I want you to notice what we did here. Before we did anything, we started with how the app needs to read the data. Only after that did we decide the structure of our data and the different primary key values. This is very different from how you would approach this with a SQL database. In SQL, you actually figure out your data model first. Why? Well, SQL gives you joins. It gives you the flexibility to read your data however you need. You decide the tables, the columns in each table, you set up the foreign keys, the access patterns. Well, they come later. But that's not the case with DynamoDB, which leads to an incredibly important mental shift. With a NoSQL database like DynamoDB, it's actually the opposite. Your access patterns decide your data model. If there's one thing you take away from this video, let it be that. All right, now this is a very simple example. Real-world DynamoDB data models get a lot more complex. If you'd like to go deeper, I'd highly recommend the DynamoDB book by Alex Debris. It walks through much more detailed examples with various types of applications, and I'll leave a link in the description. Great, you've chosen your partition key and sort key values. Now you can actually put it all in a single table. And doing so will actually reveal one of the most important ideas behind using a NoSQL database like DynamoDB. Okay, let's put it all together. We add the users and their profiles. We add their orders. And finally, we add the orders and their products. And that's it. That is our final single table design. Everything's in a single table. And more importantly, it supports all of the access patterns the app needs. Now, if you've been paying close attention, you might notice something interesting. We've actually already pre-joined the data. We didn't explicitly have to do any join operations, but the end result looks almost like we did. Users are joined with their orders, and orders are joined with their products. But there's one detail about this table that might seem strange. The same order shows up more than once in the same table. It's both under the users partition and the orders partition. And at first glance, that feels wrong. Here's the big secret. That's not a mistake. In fact, that's intentional. In the relational world, you're taught to store every piece of information exactly once. And that is called normalization. When you do need related data, you just use joins to stitch everything back together. But DynamoDB flips that model completely on its head, which leads to denormalization. NoSQL is all about denormalization, and denormalization is really just duplication. And this is powerful, but it does introduce a new layer of complexity. You now have to be a lot more careful when you write the data. For example, if one of the orders were to change, you now need to make sure to update the order in every single spot. We won't go into all the details here, but just know that something like DynamoDB transactions come in very handy. So that's the trade-off. In a SQL database, you normalize to make the data easy to write and reason about. In Dynamo, you denormalize instead to make the data super fast to read every single time, no matter the scale of your app. And that's what makes single table design so powerful. But here's the thing. It isn't always the right design to use, and without understanding when and when not to use it, there's still a piece of the puzzle you're missing. Single table design works best when your core access patterns are relatively stable. If your app is still evolving rapidly and your access patterns are constantly changing, you'll end up reshaping your data model over and over again. The complexity starts to outweigh the benefit. You'd essentially design a new table every time your app changes. You'd be much better off using a relational database like Postgres. With joins, you get much more flexibility as your access patterns change. There's another very practical reason why single table design might not be the right choice for your app, and it has nothing to do with DynamoDB itself. If the team that you work with isn't very familiar with single table design, it might just be simpler to start with a table per entity. Single table design is quite unintuitive, especially with years of mental models built around SQL databases. It's harder to reason about. It requires strong discipline around writes. In many systems, doing some application level joins isn't the end of the world, especially if you don't strictly need the fastest possible read performance at scale. It's a completely practical trade-off to make. Okay, so those are some of the reasons not to use single table design. But before we wrap up, there's one more crucial detail that changes how you think about it. Single table design doesn't literally have to mean a single table. It's not like it's some hard rule. Sometimes a few tables can make sense for your app, especially if different parts of your app don't need the same data together. Instead, here are the real principles to take away from single table design. Before doing anything with DynamoDB, start with your application's access patterns. Next, choose your partition and sort key values based on those access patterns. And finally, denormalize on purpose to make sure that your reads stay fast at scale. And that's really what single table design's all about. You made it all the way to the end of this video. Thanks for sticking around. I hope you got something out of it. Let me know in the comments below what you'd like to see next. That's all I got for today. I'm Kos, and I'll see you in the next one.